Hi everybody! In this tutorial we will see a simple technique to create a movement trail from a dance performance. We use this in some moments of the hybrid short film Symbiotic Bodies, where I worked as CGI artist. Here we recorded a physical performance through motion capture and then imported it in Houdini in order to simulate the trails and other effects. In this tutorial we are going to use a free available animation from Mixamo. We will have a look on how to extract elements and form our abstract dancer, and how to create this nice trail effect from the movements. As always, you can find the scene file of this tutorial and the related links down in the description. If you like to learn Houdini, subscribe to my channel to not miss the upcoming videos. Also thank you Fabian for this tutorial's coffee, you are awesome. So, let's get ready! Welcome back and ready to start. For this tutorial we are going to use a free animated figure from Mixamo. Here you can download a variety of free characters and animations. Under the Animations tab you can choose your favorite one. For this tutorial I was looking for a long animation with strong hand movements, in order to obtain nice trails in Houdini. The Samba dancing animation ended then to be my choice, and I decided to keep this more abstract body. After logging in, you can download your file. In Houdini we are using 24 frames per second, therefore I choose the same here, and the file format is FBX. So back in Houdini, we start by importing our FBX file. We go to File, Import, Filmbox FBX. If we would use our classical file import node instead, we would import the model without its animation. Generally, you might avoid to import cameras and lights from other scenes, so therefore I prefer to uncheck this. But in the case of our downloaded file, we can leave it as default. What we are going to change is a compatibility mode, and we choose FBX Standard. By hitting play in the timeline, we see the animation. And make sure to have the real-time icon activated, in order to have the playback to 24 frames per second. Our animation is also much longer than the frames in our timeline. Therefore, let's increase it to, let's say, 600. The imported FBX file comes in form of a subnetwork node. A subnetwork is like a container, where inside you can store other nodes. This here contains all the bones and keyframe information of the animation, all stacked accordingly in a skeleton-like hierarchy. And these two nodes here contain our figures mesh. After importing the file, we also notice the color change of our property values. Also, when we create new nodes, they come with this appearance. The reason behind this is that Houdini is automatically creating a new take, which can be seen here. A take is essentially an overwriting of settings. This is very useful when you want to render out your animation in different variations or to test different values in simulations. And for now it is not so important, because we are going to remove the takes from our file. Here on the plus icon, navigate to the new Paint tab type, Mantra Rendering, and select Take List. The main take represents our default settings. In order to set the important properties as default, we drag and drop the Mixamo take onto the main one, and then we select Merge and Override. Afterwards, we can delete the old takes. Also make sure to deselect Auto Take here in the Take menu. Otherwise, all the settings we are going to make will be applied as a take. For the animation, we are going to use a simplified line figure of our dancer, which we can emit in a pop network in order to create a trail of movement sequences. In a GeoNode, we import all components of the dancer and sort them out in relation to our needs. With the Object Merge node, we can merge elements from different sources in our actual GeoNode. You can either address a specific geo or subnode, but also use wildcards to merge in multiple objects, like in the case of our subnet node, from where we need to import all containing geonodes. Here we use a slash and the asterisk sign to merge any nodes which are located inside. Also make sure to select Transform into this object in order to merge the geonodes transformation on our geometry. Additionally, select Pack Geometry before merging. This will convert every node in our subnetwork to a unique primitive. And by having Add Path attribute selected, it will also create for each element an attribute containing the path of the geonode, which we can use to sort the elements out later. As first step, we need to split the animation by its bones, joint points and mesh. The path attribute is telling us the name of each piece. We can use this to form groups with matching names. We take the Group Expression node, which allows us to simply create groups with a VEX expression. First, we group all bones together. In the VEX expression field, we can use the match function, which adds all elements with a matching name in the bone group. Hit F1 to open the documentation and we search for match. Select the function. We see we need the following: a string representing the word we are searching for and a subject, which will be the name of the primitive attribute we want to check through. Coming back to our GEO spreadsheet, we see that all bones end with the word bone link, which makes it easier for us to select them. We type match, and in brackets we use as pattern the asterisk sign followed by bone link, in order to find all names ending by this one. The subject refers to an attribute we are looking into, and that is s@path. S refers to a string value and the @ sign to an attribute. In the spreadsheet, we can see our new group and the elements inside are highlighted in orange. We remove the selected bones with a delete node. Choose the group and make sure to have the entity set to primitives, because it is where our group is stored. Create also a group for the joint spheres. Add a new group with this plus icon here. And use for the joint spheres the pattern asterisk control 1. Create also a group to separately remove these two little eyeballs here, which don't look so good in the animation. Use here the pattern asterisk I asterisk. Add the eyes to the bones delete node to remove them. So now two auto delete nodes at the end will allow us to extract the mesh and the joint spheres individually. In the first one, we delete everything except for the points. And in the second one, we delete the points in order to obtain the remaining mesh. Now we can end this step with two null nodes. Next, we create our line figure. We use our joint spheres and create single points on each position, which we will then connect with lines. For this, we use an add node. With delete geometry but keep the points, we obtain the points. To create the lines, we use and append another add node. Switching here to the polylines tab, we can add polylines in between points by typing in the point numbers in the order we want the line to be drawn. To see the point numbers, simply switch on the point number visualizer on the toolbar. While we are going to add new polylines, the point numbers can change. Therefore, it is important to leave the display flag on the previous node to not confuse the numbers. I'm going to create here 3 polylines: the legs, the upper body and the arms. When you type in the numbers, make a space between each one to separate them. At the end, we remove the unused points to have just the lines left. Now we use another add node to separately create the hands in the same way. Also make sure to remove here the unused points as well. Next we use a merge node to merge the body and the hands together. We name the add nodes body and hands, and the merge node out full body. For the next step, I also like to scale down the model to a reasonable grid size. For this we use a transform node up here right after the object merge, which might be more convenient for the simulation, which we are going to do later. A scale factor of 0.01 works fine for me. We move on in creating our dancer. Dive out, and here use another GEO node. We import the previously separated mesh with an object merge node. Remember that we created packed primitives, which resulted in having one element per object. Looking at the spreadsheet, we see that we have 2 elements and also 2 points. In order to get all the points back on the mesh, we need to unpack our primitives with the corresponding unpack node. Our aim is now to change this body to an abstract figure composed by connected lines. For this, we need first to scatter some points on the body that we want to connect. Drop down a scatter node. Inside here, we can scatter around 1000 points. And we use a connect_adjacent_pieces node to connect this. This node is searching and connecting for each one of our 1000 points the specified amount of neighboring points within the search radius. Here we select as type adjacent points, and these values here work best for me. When we hit play, we see that our lines are changing their position at every frame. This happens because the scatter node is randomly recalculating the scatter for each frame. To let the scatter stick on the mesh, we use a simple trick with the Attribute Interpolate node. This node is taking the position information of the points scattered on a static version of our mesh and interpolating it back to the animated one. To obtain the static version of our mesh, we can use a timeshift node to freeze the mesh on a specific frame. By right-clicking in the frame properties, we delete the channels and type in 1. This will now only output the geometry of the first frame. Next, we need to store the position information of the points on our mesh. This can be done in the scatter node under the output attributes tab. We check the primnum attribute and the primuv attribute. This stores the primitive number and on which UV position of the primitive the point was scattered on. Now we can connect the points to the first input and the animated mesh to the second one of the Attribute Interpolate node. The important part here is that both the mesh from the frame 1 and the animated one will have always the same amount of primitives and the same mesh topology, in order to let the node understand where to place the points. By playing it now, we see that it looks much better. Additionally, we can place at the end a smooth node to make it look nicer. Perfect. As last step, we create our trail animation. Drop down a new GEO node, and we name it Animation. Again, with an object merge node, we import our line figure. What we want to do now is to emit the figure's lines for each frame of our animation. For this, we use a pop network, which emit particles or source geometry and allows us to apply forces to them. Connect the line figure with the first input slot and dive into Node. As first step, we decide what and how often it should emit. When we hit play, we see that at the moment it is emitting points. In order to change it to our source geometry, we go to Pop Source, and under the Source tab, we can change the emission type to All Geometry. For the emission rate and lifespan, we go to the Birth tab. Here we can leave impulse activation, which creates an emission at every frame. For the life expectancy, we use 10 seconds, so that each emission will be deleted after this time. Hit play to see the results. As our performer stays always on the same spot, we are missing the nice trail effect of our movement sequence. Therefore, we could for example add a force to the emission. In between the pop source and the pop solver, we can add different nodes to drive the behavior of our emission. We start by adding a pop wind node. This allows us to add also some noise to the force. Wind velocity specifies the direction of our force. We could for example create an emission in X with an uplift. To break the static array of lines, we can now add our noise to the force. Here in the Noise tab, we can play with the values. The main ones you can focus at first are the amplitude, which defines how strong the noise pattern is, and the swirl size, to change the scale of the noise. When we hit play now, we see that it looks more organic and fluid as before. With a pop drag node, you could add some additional control over the general force by adding an air resistance value in order to keep the emission more defined. By testing different values, you can find out what works best for you. In my case, for this, I set the wind force to 8 and 1, and the amplitude to 2 and the swirl size to 10. For the air resistance, I kept the value at 2.5. Perfect! We can now start adding some additional layers. We are going to create these violet trails to have a connecting element throughout the emission. In order to get the mesh back, we can simply use a Polywire node. For this animation, I use a division of 7 and a small wire radius, like for example 0.03. We can also use the geometry points directly as input source for our Connect Adjacent Pieces node, instead of scattering new ones. Place an Add node in order to remove everything except the points. Now we can use these points as before in the Connect Adjacent Pieces node to create the lines connections. In here, adapt the values so that it looks good to you. We also smooth it with a smooth node to have the same appearance. And also for better display in the viewport, we can add a color node. We conclude animation with a merge node, where we plug in the just created lines and the emission. Now let's dive out to our GEO level and have a look at our result by switching on the dancer and the animation. So I hope you enjoyed the video. If this tutorial was useful for you, leave me a like and share this video with your friends. This would support me a lot. And I also hope to see you soon. Ciao!